Welcome, everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to perform multiple transformations on parent functions. How are we learning it? Through the composing function transformations notes and the composing function transformations assignment. When can we use this information? To recognize the similarities between problems and understand how their solutions might also be similar. How do you know you learned it? By getting a score of 4 on the composing function transformations assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. Next, we'll do our weekly raffle. After that, we'll go over the composing function transformations notes, and then I'll give you time to complete the composing function transformations assignment on Desmos. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the Reasoning with Families of Function study guide and any incomplete assignments that you may have. Let's take a look now at the composing function transformations notes. The notes begin with the learning goals and success criteria. Now let's take a look at function notation. Function notation can be written as y equals mx plus b, or any function like that, or we can write it as f of x equals mx plus b, or f of x equals x squared, or whatever the function may be. So f of x is a shorthand way of writing a function. Now, how do we alter a periodic function? So we start with y equals sine x, and if we were to take that and say y equals 2 sine x, that's going to cause a vertical stretch of 2. So now, instead of going up to 1, it's going to go all the way up to 2 and then come back down. Y equals sine x minus 1. So if we just take a minus 1 and add that to the end of it, that's going to shift it down 1. So it's going to take the whole thing and slide it. Then what if we had sine x minus 1 all together? That's going to be a horizontal shift to the right 1. And then if we were to take 2x inside the parentheses now, that's going to do a scale factor. Notice anytime we have these parentheses, we're always going to go the opposite of what you would think. So instead of multiplying by 2, we end up dividing by 2. Instead of subtracting 1, we really end up sliding to the right or adding 1. So anytime it's in the parentheses, it always goes opposite. But if it's outside the parentheses, it does exactly what you would think it would do. Now, how do we perform operations on a function? So without knowing the actual equation of a function, we can determine how a function will change by placing it under an operation. For instance, if I take and double any function, it's going to create a vertical stretch of 2. If it was 3 times f of x, it would have a vertical stretch of 3. If it was 1/2, it would have a vertical stretch of 1/2. So the number in front causes a vertical stretch. If we put that number inside the parentheses, so we scale the inside the parentheses, it's always going to have the opposite effect. So it's going to cause a horizontal stretch of, in this case, 1/2. Now, if this was 3, it would have a horizontal stretch of 1/3. If it was 1/2 in here, then it would have a horizontal stretch of 2. Now, if we add a constant at the end, it's going to cause a vertical shift up or down. So this is plus 1, so it would slide up. If it was plus 5, it would slide up 5. If it was minus 4, it would slide down 4. Now, if it's inside the parentheses, so x plus 1, it's going to shift us again. It's in the parentheses, so it's going opposite, so it's going to shift us to the left 1. If this was plus 8, it would shift us to the left 8. If it was minus 8, it would shift us to the right 8. Now, 2 f of x plus 1. So now we're combining two different things. So now we're going to have a vertical stretch of 2 because of the 2 in front. And then the plus 1 is going to slide us up 1. So we end up with two different transformations there.
Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. And it's going to pop up with our email accounts. You're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click Start the Activity, and it will take me into the assignment and allow me to begin. So that's how you will log into Desmos using Google.
Let's take a look now at the composing function transformations assignment. The assignment begins with the learning goals and success criteria. If we scroll down, there's a link here to take you to the Desmos activity. Go ahead and click on that link. And it should take you to a page that looks like this. We'll go ahead and click Start the Activity. The activity begins with the learning goals and success criteria. We'll go ahead and click Next. It says what transformation is required for the function here. So we're going to take this and multiply it by 1/3. Well, anytime we have a number in front like this, that causes a vertical stretch. So this is a vertical stretch with scale 1/3. So that's our statement there. Then for this one, we're going to scale the x in here now. So that causes a horizontal stretch with scale. And remember, it's always going to be the opposite anytime it's in parentheses, so 1/2. So this would be our answer. And we'll continue to do that for each of these. And then we'll click Next. So now this one requires us to figure out the transformations. They always go in order. So we're going to have a vertical stretch of 3. Then after that, we go here, and we have this -2. So that is a horizontal shift to the right 2, because it's always opposite whenever we're in parentheses. And then here, this is a vertical shift on the outside, so this is a vertical shift up 1. So that's what we would state, and we do that for each of these. Then we'll click Next. Now we're going to state the transformation that's going on based on the graphs. So this is just a translation, so it's slid over and up. So we would add in those values. Then here we can slide over, and then notice we need to scale it up, so we need to dilate this. So we're going to create a vertical stretch here. So you'll go ahead and enter that in. Then for this one, you'll do the same thing. Now we started here and need to go to here. So now we need to shrink it down, so that's a horizontal stretch of a fraction. And that should take us back to here, and then slide it down. And then when you're done with that, you'll go ahead and go back to your Google form and click Next. This will take you to your before you go. Go ahead and fill out your before you go, and then submit your work on Google Classroom.